Hello, my name is Kaelyn Yang, and I will be hosting the Intro to Databases workshop for this Hoth. Okay, first we have our overview of what we will be covering today. So first, what is a database? Purpose of databases, different types of databases. We will be setting up an example with MongoDB, CRUD operations, and examples of CRUD operations with MongoDB, and lastly, a demo. Okay, first, you might be wondering, like, what is a database? You might have heard it a couple of times, but like, what does it like actually mean? Maybe you're thinking like, you know what data is? Bunch of information. Maybe a base, right? Or like one of these kinds of bases. Let's start with like what actually is data to be specific. Um, Data is any information that is raw, which means that it's not edited yet or processed. You might be familiar with this term if you do photography. You take pictures and you have like raw images, right? And then you typically edit those photos. Examples of data in general would be like words, symbols, numbers, audio, or video files. Here I have some like examples of what data would be. It could be the audio file or video file. Okay, now what is a database? Databases are containers to store the data or information in organized and easily accessed way. They can include tables with rows and columns, indexes that allow for easier access to the data, and information on how to control or manage the database, which is called database management. In my picture, you can see that I have a table here with ID numbers where the indexes can like access the ID numbers, and the IDs represent like a certain spot where the data is. Here's what this looks like visually. Let's say that you have a bunch of unsorted data and you wanted to organize them based off of the data type. It could be pictures, audio files, or text. Here in my example, I have like Hello Hackers, Hack on the Hill, this picture of a red panda, and some audio files. Okay, so now we have our containers, and which is your database, and you want to sort them. So there's a container for pictures, audio files, and text, and then you'll be able to, with your database, sort your data so you can easily access and know like what kind of data you're accessing. Of course, it doesn't have to be based off of like type. You can choose um, whatever categories you would like. In this analogy, my data was the pictures, text, and files, and then my database was the shipping containers. Okay, now you might be wondering, like, why do we even need a database in the first place? Like, what happens if I just have the unsorted data? So here's some purposes of databases. Databases are really essential and helpful to make projects in general. Some of the key points being that you get to store data that you want to reference later. And other benefits include security, efficient, and most importantly, making cool things. I have this picture of a container ship. Maybe like you can see like your container ship is your project, and then like back to the analogy, the shipping containers are like your holds your data, and you can see like everything's like clean, concise, you know where everything is. Okay, there are several types of databases. However, the two main types of databases that we will be focusing on are NoSQL and SQL. A quick overview of like going over the pictures that I have. You can tell on the left that SQL is definitely like more strict. It's this like nice container, which represents like it being more table focused. And NoSQL is more flexible and uses indexes. You can see with the colored circles, how it kind of just like points to each other. So that would be like an example of NoSQL on like a high level. top-down view. Okay, so to be more specific, SQL is a type of relational database, while NoSQL is a type of non-relational database. Here I have some comparisons between the similarities and differences. Relational databases have predefined categories. It's very important that the data is consistent, it is accurate and reliable, and it can handle more complex queries, which, for example, could be joining two tables of information together. And then on the right, I have non-relational, which some pros would be that it can handle large data volumes. It is low latency, which means that there's not much delay when sending over your data. And the data models are more flexible, and it is faster at reading and writing data. On the some similarities that they both do is they both are great for data storage. They both use CRUD operations, um, great for security, and they both use indexing. Don't worry if you don't know what like CRUD operations are yet, we'll get into that later. Okay, so SQL. SQL stands for Structured Query Language. It is a type of relational database. They use tables to organize the data in columns and rows and uses SQL to access the data. Here it is, if you have like this project, it's best for strict and more complicated requests. Examples of this could be like banking systems where you need everything to be like precise. You need to have like the account number, the name, and maybe like their balance. You wouldn't have maybe like, oh, but on the other hand, this account has this as well. It wouldn't like quite make as much sense. And then another example would be university systems. Here I have some pictures of SQL programs from companies. You have Oracle, MySQL, and Azure SQL. And then we have NoSQL on the other hand. It is a non-relational database. It is flexible, faster, and better for scaling projects. This is ideal for big data, real-time analytics, and IoT, which stands for Internet of Things. Examples of when you would use NoSQL is like catalog management, chat applications, where like you can like where you really need that real-time analytic, and then e-commerce, which is online shopping. Examples of NoSQL platforms are MongoDB, which we will be using later, Couchbase, and Redis. Okay, now we are going to start with an example with MongoDB so you can like get your first database started. MongoDB is a NoSQL program that is source available, cross-platform, and document-oriented database, which means that it's great for beginners and just starting off. Okay, so I'll go over like my slides and like what we will be doing, and then I'll actually go through it myself. So first you want to create a new account or log into MongoDB if you already have one. You want to first create a new project after you log in. You can name it, as you can see in the bottom left, and then to the bottom right, you will be given an option to create your cluster. And then you can also name your cluster. Next is deploying your cluster. You can choose different payment plans depending on your project, but for just starting off and learning, having the free cluster works great. Okay, and then you want to allow access from anywhere. Um, Next, you want to make sure that when you're creating a database user to access your database, to save the username and the password somewhere safe. That way, in our project, you can like access it and reference it in your project. I'll show you use it in your .env file, which looks like this. It's where you would use your password. You can see that like admin would be where your username goes, and then your password 123 is the password that you put in. Or you can use the auto randomated generated password that they provide for you. Okay, so I will get into how to do that with MongoDB. Let me just switch my, oh. Okay, see here I have logged in and I can see all of my projects. I will create a new project on the right, and then I can name my project, so I can just name this like Hoth Intro to Databases. You don't need to do this. This is optional. Next. I would just you can this is great for like if you're working in a team, so you can like add your members here. That way you can all access the database, but for me, I'm just like accessing it by myself, so I'll just create the project. See, here we have creating the cluster, and then I will deploy my cluster. I'll choose the free option, and then I'll just leave it as cluster 0 and then the default options that they give us. Great, I have my cluster. You can see that I have my username and my password, which I'm gonna save somewhere. And then I will save my password. Great, and then I'm going to create my database user. And then I will connect, and then we will get into this later. But that's how you create your first database with MongoDB. Okay, so back to the slides. We will be going over the CRUD operations. I will also have like a live demo at the end of this to see everything working with the database, and I'll just like go over everything again. And you can also like see everything come together. Okay, so CRUD stands for create, read, update, and delete. First, to use actually the CRUD operations, you need to create a schema. Here I have an example of my schema. I created like a separate folder to hold my models, and I have JavaScript to, I used JavaScript for my schema. Um, I here for my like first line, I have require mongoose, which just allows me to use the mongoose library. Then I have my student schema. I create a new schema with mongoose, and then I set the attributes to it. I have, so like my attributes would be student ID, name, role, and birthday. The last two lines creates the model and connects it to the MongoDB database and exports it so that all of your other files in your project can also use it. Okay, so create is inserting data. Here I have an example of the create operation. It uses the post request, which you can see with the dot post, and it is at the slash save endpoint. This means in your URL, it will end with like slash save. However, it can be whatever you want. I just chose to use save. But if you do something like maybe say like slash create, that's totally fine. You can name it whatever you want, as long as you make sure to keep it consistent when you're like creating data. It is an asynchronous function. This will mean that I could use the await keyword, as you can see down here in the middle. and it will await to create that new student. But first, in my try block, I will print that it will have received the body, and then it will, from my schema, create a new student model, and then it will dot save it. We will use the save function, which means that it saves to the database. If you don't use the save function, then the information won't be stored into your database. And then I have a print console.log here that just lets me know what that the create operation was successful and the student that I had just saved. However, if it runs into any kinds of errors, it will catch the error and let me know that this operation failed. Okay, here I have read, which is finding data. This retrieves existing records from your database. This time it uses a .get request at the /findAll endpoint. It is also an asynchronous function, and it tries to return all of your data in your database, and it'll send it back to you. If not, it'll give you an error and tell you that it failed. Okay, next we have update, which is modifying existing data. The update uses the .post request at the /update endpoint. And you can see in the try block, I have the find by ID and update function. This is a function that Mongoose provides, and it allows you to modify your data based off of the unique ID that you are given whenever you create data. It's the index, like identifier, when it enters your database. In this example, I have it updating the name of the student I'm trying to update. It also catches that if the student does not exist, then I have it return an error to me. But if not, if it was successful, then I let it know, I print out that it was successful. That way I know that my operations worked. And then lastly, it sends the student back. Okay, so the last CRUD operation we will be going over is the delete, which is erasing any data in your database. This could be like, for example, in our example, we're using students. So let's say your student graduated and you no longer want to keep their information in your database. You would use the delete. Delete uses the .post. I have it at the /delete endpoint, and it uses the find by ID and delete function by Mongoose. And I input the ID that I want, the ID to the data that I want to delete. Similar to the update, if the student does not exist, then I send an error, but if it worked, then I send a message back that it worked and that the delete function sends back the deleted student. And then I have the same error catching. Okay, so here I have the necessary things to start up your backend directory and initialize it. As again, I will just be going through the slides as an overview of what we will be doing, and then I will actually hop into it myself. So in your project, you want to run these commands to initialize your backend. The first command makes a folder called backend inside your project, and then cd backend traverses into the folder, and then npm init -y, it initializes a new node.js project and says yes to all the setup prompts. However, you could totally run it without the -y, and it would still work. npm install express mongoose cores.env. This basically installs all of the packages that we will be using. Express is the backend web application framework for Node.js. Mongoose is for our MongoDB database. Cores allows us to access resources from different origins that might not be in our current origin. An origin is just a domain, protocol, or port. And then lastly, the .env is to have our local variables with the sensitive information, such as like our passwords, to be kept separate, and it would be ignored if you were to use GitHub and upload it to your project. You also want to make sure that you create an index.js file and a .env file. You can create new files and folders with the box I highlighted here. An example of a basic backend, your package.json file is created automatically for you. However, I edited it so that I added the dev command. So instead of having to run in my terminal npx nodemon index.js, I find it easier to just run npm run dev in my terminal. Here is an example of a basic backend. This is like your index.js file that you just created. At the top, we have the lines of the packages that we installed. So I have like Express, Mongoose, Cores, .env, and then I also included the student model because just for like this example, I'll be like using my CRUD operations in my index.js file. And then the next line after the requires is the .env.config. This just configures our .env file and makes sure that we can use the variables inside of it. And then lines 9 to 11 just sets up our backend with express.js called app. And then we connect to our port if it's missing from our .env file or there's an error accessing it for some reason. It will use port 5001 by default. Next, we have Mongo underscore URI. This takes our Mongo URI from our .env file as well. Next, we connect to our MongoDB database with our URI from our .env file. It will either print that it connected to MongoDB, or it will tell us that there is an error connecting to our database. Then we run our backend and listen to the port. It will tell us that our API is running and that we are listening to the server is listening to port number. I made it dynamic. That way you are given the correct information if you were to change your port number. Okay, demo time. Look at this cool horse I found. It's so cool. This is like me understanding Intro to Database Workshop. Yep. Okay, let's see. Me switch sides. I will. Okay, here I have my Visual Studio Code editor pulled up and I have my terminal open. I just used a folder that I named hot. Okay, so in our terminal, I am going to run the commands to make a folder for my backend. Here you can see like it creates one, and then I'm going to go to that backend. You know that you're in the backend because it'll like be like slash backend. Then I will npm init dash one. And then you can see that like it creates everything for me and it like prints out that everything worked and was successful. Then I will run npm install express. mongoose cores and .env. This will just like take a little bit and install the packages required. Nice. So everything worked great. And you can see that I have my package.json, my node models, everything that was initialized for me. In my package.json file, I'm just going to edit it so that I also include the line, the dev line that I had talked about earlier. So this way I can just type npm run dev in my terminal. Okay, save that. And then I'm going to create my index.js file. Make sure that's in my backend. Oopsies. Yep. And then I will also create my .env file. And then it's a period env to create it. Okay, so we'll get started with the .env file first. I'm just gonna go mongo underscore URI equals, and then this will be the string from before. I'm just going to pull that up really quick, copy it over from MongoDB. And then I will have my port number as well. I'll do 5001. Okay, great. Then I will create my model for my schema. So I'll create another folder under the backend. I'll call this models. And then I will create a file called student models. Actually, I'll name it student schema because that makes more sense. Student schema.js. And then I had already written in it, so I'm just going to copy and paste that over. But this is just everything that we've already covered. And it looks like this again. And then I'll move over to my index.js file. I'm going to test out the credit commands in here. So you can see that like I have all the delete, find all, and save. Okay, great. And then I have everything I think I need. So I'm going to do npm run dev in my terminal. And then you can see that it like tells me that I'm running my server on port 5001. It connected to MongoDB. So it seems that there's like no errors and everything worked. Okay, so to test my CRUD operations, I'll be using something called Postman. Okay, here I have Postman pulled up, and Postman is a tester that lets you to run your commands and make sure that everything is running smoothly. You can see your request and what's happening on your database. Okay, so here I'm just going to my workspace, and then I can create a new command here. So like, let's say I wanted to create data, I can call this create data. And then creating data is a post request, so I can change that here. And then I had my, please, sorry, that was from before. And then I have my endpoint being /save. Your endpoint could have been like /create or something, but I have mine as save. And then in the body, I had typed in a student I had created. So this student would have like ID one, the ID number 1. Their name is John, their roll number is 12, and this is their birthday. This is a raw JSON file. And then I can run it to see if it works. Great. It told me that the data has been inserted, and I can create like, say, another student. Let's call the student like Steve. Let's change their student ID and stuff. Let's say they have the same birthday. And then I could also send this, and then it'll let me know that the data was inserted successfully. Okay, so now let's see. We can fi use the find to make sure that all the commands worked. So let's do find data. And then I have mine as slash find all, and this is a get request. I could just run it without any body because I'm just looking for all of my data. And then you can see that I have it returned to me the students that are in my databases and that it also has their unique ID identifiers. So like here I have John and I have Steve. So let's say I want to remove John from my database. I will copy the ID, the unique ID that it gives me, and then I will create another get request to delete. No, I will create, sorry, I'll create a post request to delete. And then in the body, I will just have like, this way it knows what ID to delete and it tells me that it deleted John. And then I could double check this with my find and I can see that John has been deleted from our database. So that's it for Postman and our demo. You successfully made your first backend. If you wanted additional resources, here is the MongoDB documentation, just in case you were confused on anything or you wanted to learn more. Thank you and happy hacking.